Hi there, I'm John from CNCKing.com, and today we're going to weld a custom desktop organizer. My shop has lots of little projects here and there, and the problem that ends up happening is you end up with lots of little odds and ends, little pieces of tubing, plate, all that kind of stuff. And even when I do CNC plasma cutting, you always end up with little bits here and there. And the last thing you want to do is actually throw them away or send them to the salvage yard. And the reason for that is because that one piece that sat on the shelf for 3 years that you thought, oh, never use it ever, the moment you bring it to the salvage yard, that one piece will be needed for a customer project, and now you got to buy 24 feet of tubing because you needed 3 inches of tubing to finish a project. So in this case here, we have tubing. It's all different specs, it's just random stuff. And it's all welded together. Now the process I used for welding this is flux core arc welding. So that's with the little gun. And I use that for tack welding because it's very fast and efficient for doing that. After that, I switched to electrode 70-14 instead of 70-18, just because I wanted to mix things up a little bit. And it does have some characteristics that are different than 70-18, so we'll review that as well in this video. I have a scrap pile with lots of different pieces, so the first thing I did before I did any of this cleanup was actually deciding which pieces I'm going to use, and also doing a dry fit to make sure everything fit properly the way I wanted it to fit. It took quite a bit of time to get that sorted out, so that was pretty easy. The next step after that is cleaning up all the surfaces. Now there's two ways I did this in this project. The first one was using a file and an angle grinder, as you can see here. It actually did a really good job. It was almost like carving metal with the flap disc, and I kind of enjoyed doing that. Now the reason why I'm doing this is because if you're welding, you want a clean surface to weld from, because you gotta remember, welding is closing a circuit. And if there's any interference, such as paint, burrs, or what have you, the result from the welding will not be the best. So basically, the cleaner the surface areas that you're working from, the better the weld, the better the penetration, the better every aspect of it. Even the way the weld actually looks will be much better because you have that much less contamination on it, right? So after doing all of that, the next step was to throw it into the sandblaster. What the sandblaster did, it gave it a really nice texture. I use glass beads because I kind of enjoy doing that. And with the glass beads, what it does, it gives, it just mellows out the metal so that when you do the painting at the final step, it actually adheres nice and evenly everywhere. It also removes all the paint. It removes any other debris that could possibly be on there that maybe the angle grinder or the file missed. It just kind of smooths everything out really, really well. Now for the PSI, I'm using 120 PSI on this. So, that glass is flying out of there really, really fast. So that's why, I know the angle with the camera isn't really the best, but that's why when I'm holding it, I try to use something else to hold it, because I don't want to burn a hole through the gloves, because those gloves are kind of expensive to work from. Now, when I'm using the sandblaster, I'm using the sandblaster on all the edges, everything that I could possibly use on. And the reason for that is because any sort of defect, I want to get rid of it now. If you have a defect and then you do the weld and then you do everything and try to fix it afterwards, it's a lot of trouble because going back on work that you've already done is always a hassle no matter what you're doing. Now for this specific project, I chose 70-14, which is this one here. You can see the numbers on there. And this is 70-18, which I didn't use. Now there's a couple of major differences between these two rods. 70-18 is good for dynamic loads, so making something that pushes and pulls, moves around really fast, or differences in heat. So when I made the fire pit, I used 70-18 because you have hot embers and stuff on one side of the fireplace or the fire pit, not so hot on the other one, so you might have some contraction, expansion, all that kind of stuff, just from the heat affected zone all around the fire pit. And of course, the fire pit is really, really hot, and then it cools down, so the metal contracts, expands, contracts. So 70-18 was great for that. 70-14 is more for static loads. And what that is, let's say you have an air compressor and need a bracket to hold it up on a wall. 70-14 is great for that. The major differences between these two rods, this one here, 70-18, needs a rod oven. And I have that here in the shop. I find when I'm doing arc starts and I'm just starting a weld, if this is blazing hot, it works wonderfully. Now 7014 doesn't need a rod oven because it's not a low hydrogen rod, which basically means that it's very easy to start. If it gets a little bit wet, no big deal. If this one gets wet or has problems, right away in the weld you start to see problems with porosity, which is basically like little bubbles you see in the weld zone. And you can also have other issues with cracking later on, a week or a year later on, depending on what you're doing. So this is a very, very finicky rod, but it's used mostly for structural steel. Think bridges, airports, all the stuff that, you know, if your life depends on it, 7018 definitely is what they use, especially even for piping and all that kind of stuff, that whole industry. 7014 again is generally considered a dummy rod as well. 7014 will start very easily, makes a really nice weld. It's very easy to learn as a beginner. And for me, I didn't learn using 7014. I learned using 7018. So I technically learned the hard way how to go about do welding at the college. Now they can be used with other rods as well. So generally, if you want to do a root pass, so just think of, you know, you got a piece of metal coming like this, and you want to get a lot of deep penetration there. You'd use like a 6010 or 6011 to really carve into that. And then what do? You clean up the weld, and then you use one of these rods. These rods produce a nice visually appealing result, while the other ones are just focused on deep penetration. The penetration of these two rods is about the same. You can't really see much of a difference. Now in our college, whenever we do tests, because you know you do a lot of welding, then you look at how to break your weld and see what the results are. If you want to know if you have really good penetration in your weld, basically just make a T-joint and weld all the way down, and then you break it the other way. And if you see it like a saw, that means you have awesome penetration. If you just see a clean break, that means you basically had no penetration. So although the weld looks really, really nice, it's absolute crap. So here you can see me cleaning each part twice. The first time is because I sandblasted this using glass beads. So of course the glass breaks up and shatters while it hits this and cleans the surface. Now that produces a very, very fine dust, and that fine dust is not really good for much of anything, especially when you're welding or painting. So what I'm doing is first I'm removing all that dust, and I throw those towels away, and then I do it again using acetone to make sure everything's perfectly clean. And then after that, I just let it sit till everything dries out, and then I could go ahead and do the tack welding, which is what you see me do here. Now, I was a little bit smart ahead of time because I said, you know, I'll do one tubing at a time and I'll work my way around and I'll do this. One of the mistakes I did is I should have actually welded all the way around using either the flux core or a smaller rod, smaller diameter rod, because I had a lot of problems trying to get into small areas. And if I would have welded all the way around as I was making these, it would have been so much easier to work from, and I think the results from the welding would have been a lot nicer. That being said, tack welding is plenty strong for this application. These are desktop organizers. It's just going to sit on a desk. You know, nobody's throwing it off an airplane or anything like that. So because of that, even just tack welding, it would have been fine aesthetically, and I think the paint would have filled in any sort of the small gaps that existed. So that's something to consider for the next time. As you can see here, I'm using a 1/8 rod, 7014, and this is going to be a static load, so in that case it's a perfect rod for it. I didn't have my rod oven on for this project because I don't need it. You only need it for 7018, not 7014. And the welding actually went really, really well. Now, some of the changes that I would do when I was welding it is I'd try to make sure that I would have all the parts as flat as possible when I'm welding it, like what I just did here. Some of these parts I was trying to be, you know, really, really cool and doing it out of position. And I don't know, it worked, but it wasn't feeling right. So that's something I got to keep in mind later on. I can also add a lot more welds when everything's flat because you have gravity working for you instead of against you. And here I am again using the angle grinder, and that's just cleaning everything right up. And of course I had to throw it back in the sandblaster because I had some slag inclusions and some slag inside of small areas that I just could not get to with the chipping hammer. So as a result, sandblast again. So as you saw, there are quite a few challenges with making this. This is the first time I make it. One of the first challenges I found out after welding it was, I'm just gonna put this over here, it's about 5 pounds, it's pretty heavy. So one of the first challenges I found out was when I did the tack welding with using the flux core, it came out really, really nice. Then when I started using full welds, I started to have problems. And the problems were not because of the weld, or problems because of the pipe. The problem was access. More specifically, you know, you're trying to weld inside of areas over here, and you just can't because it's too tight of a weld. So one way around that would be, of course, to put it this way and weld it all the way up, but I didn't want to do that. Another challenge I had was removing all the slag. Basically, the slag is just a buildup on top of the weld puddle. And so when you're done welding, you have this thick layer on top of it, which you chip away using a chipping hammer like this. So that's why you saw me chipping away at it. Now, I can't chip away in small little areas, so that's why I ended up having to use a sandblaster to sandblast everything all over again. And I found out very quickly that sandblasting using glass bead doesn't really work very well with slag. So that's why I say paint is a wonderful coverall, because there's definitely some slag on this, but you would never notice it because it's got paint over it. And the paint just covers everything, makes everything look uniform. So if you're looking for custom welding, contact me at CNCKing.com. We can make it for you and ship it right to your door.